Hey boys and girls, and welcome to our math lesson today. Yes, I am standing inside what would be our classroom if we weren't virtual, but I had to come into work today, so that's why I'm recording from work. But today what we're going to do for our math lesson is just a little bit of review. So we're going to go over 10 more, 10 less, 1 more, 1 less, go over some strategies of how to solve those problems. We're going to go over a couple word problems, and then we're also going to go over defining and describing shapes, and then also composing shapes to make new shapes. So let's go ahead and get started with 1 more, 1 less, 10 more, 10 less. And I already have my number on the board, and I apologize, there's not much I can do about the lights if the lights are glaring on the board. But if you need to, go ahead and grab your 1 to 120 chart. You can always use a penny, a bead. You can put it in a sleeve like this one. You can use a dry erase marker if you have a sleeve. But anything you use, you can use, anything. If you have any clear gems or stones or crystals or whatever, you can put that on top to save your number. And then once you find your number, that'll really help you with 10 more, 10 less, 1 more, 1 less. Another way to think of it is our number is 52. So we're basically looking at it as 52 plus 1, 52 minus 1, 52 plus 10, and 52 minus 10. Okay, so that's how we're looking at our tic-tac-toe board, right? We're looking at it as 52 plus 1 more, 52 minus 1, 52 plus 10, and remember going down the hundreds chart, you're adding 10. By going up the hundreds chart, you are going 10 less, so you're going back 10, okay? So, and this one's 1 more, 1 less is a little bit easier because it's kind of like you're looking at it like a number line. So if you're going backwards, you're hopping backwards, that's less. If you're hopping forwards, that's more. So 52 plus 1, right? If we put this into a simple, TO chart, so 52 plus 1 more, 2 plus 1 is 3, 53. So this is my answer here, 53. Okay, if I took this and I made it minus 1, 5 minus 0 is still 5, but 2 minus 1 is 1. So 1 less is 51. Don't forget to double check. You can go 51, 52, and 53. Apologize for the bell. Okay, now if I was to do 52 plus 10, okay, 2 plus 0 is 2, 5 plus 1 is 6, 62. Remember, when you're doing the ones, for the most part, the ones place is the place that changes. When you're doing the tens, okay, this is the place that changes. Okay, then if I did subtract 10, okay, 2 minus 0 is still 2, 5 minus 1 is 4, this is 42. Same thing here. You can count going down. You can do 40, 50, 60. Okay, and you should know it's 42, 52, 62. So this right here, the ones place when you're doing 10 less and 10 more, shouldn't change. Okay, all right. I apologize for my eraser. My good erasers are so this one's a little smeary. Okay, so let's go to our next one. 1 more, 1 less, 10 less, 10 more. Okay. And remember the beauty of Mrs. Cooper being recorded. If I ever am going too fast for you, you just go pause. Remember what we talked about yesterday with the world would be a perfect place if lima beans would be illegal. We talked about that that book that with all those quotes from all those kids that if you could have a remote where you could like pause and mute people. So just pause, Mrs. Cooper. Pause. And I'll freeze and then you can hit play again. Okay. So the next one I want to go over is the number 20. Okay, so remember this can be thought of as 20 plus 1, 20 minus 1, 20 plus 10, and 20 minus 10. Now I know what you're thinking. You're like, oh, this one's going to be easy. But where these ones are tricky are when we do one less. So if we, again, popped it into our TO chart and we wrote in our 20, and we're going to add 1. 0 plus 1 is 1, and you bring down the 2 because 2 plus nothing is 2, so that's 21. And then one more, if we do one less, this is where it's tricky, okay? Because this right here doesn't work, 20 minus 1, right? So, because the 0, you can't take away 0, you can't do 0 minus 1. You can't do it in first grade at least. So when you're doing 0 minus 1, well, if you have nothing, no, you can't do it at all. If you have nothing, you can't take away 1. So you have to borrow from the 2 to make it and you borrow from the 2, and then this becomes a 10, and this becomes a 1. So you have to borrow, so if you borrow and this is a 0, you borrow from this, and the next number that would occur is a 10. This becomes a 1, and then it's 1, 10 minus 1 is 9. So another way to look at it is if I had 2 10s and I need to take away 1, well, I don't have any 1s. So you have to decompose a 10, okay? And then you have to make 10 1s. And then you can take away a 1. But now see, this 10 is gone. This 10's bye-bye. So there's only 1 10 left and 9 1s. Okay. All right, and then 10 more than 20. What's 10 more than 20? 10, 20, 30. And what's that 10 that comes before 20? 10, right? So that is your 10 more, 10 less, 1 more, 1 less. Alrighty. Now we're going to pop into and we're going to solve a couple word problems together. Now something I noticed from your math activity yesterday, a lot of you struggled with the one that was comparing. So for example, if I did, let's see, I'm trying to think of a student's name, but I'm having some trouble. Bristol has 6 calico critters. I know you have more than that, sweetheart, but just a word problem. Okay, Bristol has 6 calico critters. Zoe has 10 calico critters. Okay. How many fewer critters does Bristol have than Zoe? Okay, so a lot of you were confused about this. So it wants to know how many fewer Bristol has than Zoe. So there's 2 ways you can write this equation. You can write this equation as 10 minus unknown because we want to know how many fewer she has. We want to know how many fewer. What's this missing number? 10 minus unknown equals 6. You could also write it as 10 minus 6 equals unknown. Now, a way to solve a comparison problem when it's asking how many more or how many fewer is you can draw out your 10 pieces and your 6 pieces and line them up. Okay, so for example, I'm going to draw 10 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to draw 6 circles right beneath it. And then I'm going to see what's missing, right? 1, 2, 3, 4, 5, 6. So now I see that they both have this many, but then this is how many that's missing. So there's 1, 2, 3, 4. Okay, so 10 minus 4 equals 6. 10 minus 6 would also equal 4. Okay, remember this strategy was the one that we learned in Big Ideas Math. Okay, most of you did really well with your word problems though, so I'm really proud of you. I'm really glad that a lot of you like using that part-whole model. You also like using the open number line, which is a really great strategy for 2nd grade. So awesome. Okay, so now let's do another one. Let's do, let's do Grayson. Got to add you in there, buddy. He had some marbles. Okay. He bought 3 more at the store. And maybe they're really large marbles. Now, Grayson has 10 marbles. How many marbles did Grayson have to start? Okay, so Grayson had some marbles. He had some, right? He bought 3 more. He bought 3 more at the store. Now he has 10. Okay. I personally think the easiest way to solve this is with a part-whole model. Okay. So I'm going to do that over here. Okay. Remember, in addition, it's part plus part equals whole. In subtraction, it's whole minus part equals part. A lot of you were confused with this one here. Got to make sure that whole is first. Because remember, whatever is in this entire graph or in this entire chart has to equal this number down here. So 10 is our whole. We know 1 part, which is 3. Okay. And then what we're going to do is we're going to put 3 in our head and we're going to count on until we get to 10. 4, 5, 6, 7, 8, 9, 10. Then we know 3, we know 10, so that means this is our unknown. Okay? 1, 2, 3, 4, 5, 6, 7. 7 plus 3 equals 10. Okay? That's how you solve one of those ones with the start unknown. I think a part-whole model is the easiest way to solve it with the start unknown. You could do an open number line, but you wouldn't know your start. So you'd kind of have to work backwards. So I know some of you have done that before where you'll start with like 10 and then work backwards. So you do 10 and then do 3 hops backwards to find number 7. And that works too. So you just kind of switch your equation around. Okay. Now, before we wrap it up, I do want to go over some of your shapes. So, for example, what shape is this? That's right, this is a circle. It has 0 sides and 0 vertices. Right. Okay. What shape is this? That's right, this is a triangle. It has 3 sides, 1, 2, 3, and 3 vertices, 1, 2, 3. Good. What shape is this? A square, right? How many sides does it have? 4, right? And it has 4 vertices. Now, something that makes a square different from this shape is that all the sides are the same, right? On a square, all the sides are the same. Now we have a rectangle, right? And a rectangle is different from a square because it has 4 sides and 4 vertices. That's how it's the same. But it has 2 sides that are longer and 2 sides that are shorter. So it has 2 sets of 2 sides of the same length, right? What is this shape or this shape? Right, this is a trapezoid, right? And it has 4 sides, but what makes it different is it only has this set of parallel sides. So remember, we've talked about this a little bit, that if these 2 sides went out, they would continue on forever and ever and ever, and they would never touch. But these 2 sides, if they kept continuing on, they would eventually touch. Right. Okay. And what is this shape? Right? This is what Big Ideas is calling a rhombus, right? So this is a rhombus. And a rhombus is, right now it's kind of looking like a diamond, but we know that it kind of is a square just tilted on its side. Okay. And this is a pentagon, right? And a pentagon has how many sides? Right? It has 5 sides and 5 vertices. Kind of looks like a house. Then we have a hexagon, right? And remember, hexagon and 6 both have X's. 1, 2, 3, 4, 5, 6. 6 sides, 6 vertices. Just a couple left. This is a squish circle. It's an oval, right? There's 0 sides, 0 vertices, but it's not the same width all the way across. So like this from here to here is called a diameter. Big words, but from here to here is different than from here to here. But on a circle, no matter which way you turn it, the distance around this in between from one part of the circle to another part is the same. And then this one we've went over briefly. Remember, it's like a stop sign. It's a 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon, right? Like an octopus has 8 legs. Octagon, right? It has 8 sides and 8 vertices. All right, so now what we're going to talk about is going over how to compose some shapes. So for example, I want to make this shape right here, okay? What 2 shapes could I put together to make that shape? I could use 2 triangles, right? I could use 2 triangles. If I were to draw it, I'd put a triangle on the top, and then I just flip it over. And remember, mine aren't perfect either, but I just do my best, right? So you can use 2 triangles to compose a rhombus. Okay. What if I said I would like to use 2 squares to make a rectangle? So I know a rectangle is going to look like this, right? Or straight up and down. So if I were to use 2 squares to make a rectangle, I might draw a square, right, to the best of my ability, and draw another square. Or like, I think this one's a little too long to make it 2 squares. But like if I made this a square, something like that. Not quite the same, but as long as you could tell me that those are 2 squares that you use to make a rectangle, that's all I care about. Okay. All right. Let's keep going. What if I wanted to make a hexagon using 2 trapezoids? So don't forget, sometimes it's easier to draw out the hexagon first and then divide it in half. Sometimes that's easier. You could draw a trapezoid on top and a trapezoid on the bottom as well. You could go like this and then continue on the bottom. Okay, that also works. I can tell that's 2 trapezoids. Hold on 1 second, friends. Hey guys, okay, so sorry. So let's keep going over some different ways. Now, what if I wanted to still make a hexagon, but I wanted to use some different shapes? I don't want to just use 2 trapezoids. Now, there's a couple different ways I could do this. I could use, I don't have any more. I might not. That's okay. I have a brain. Oh no, here it is. Okay. So I could use, right? I could use some triangles down here, right? To make a hexagon still, right? I could do some triangles. I could also make a rhombus in a triangle, right? To make a hexagon. Okay, I could also use, if I didn't want to use this trapezoid up here, I could use 3 triangles, or 6 triangles, I guess I should say. 6 triangles to make a hexagon. I know that's not perfect, but guess what? That's okay. And that is all I have for you for composing shapes. So do your very best work with your review. I'll make sure that I stay throughout the day checking on it, make sure that you're understanding how to do your work. And I miss y'all. Some of you I get to see you today for a small group. And I'll see you all for the SEL check-in. But have a wonderful rest of your day, and I miss you. Bye.